All right, so let's zoom in on this bad boy. Take a look-see. All right, it says here's a bunch of data we saw in Chapter 6 about a bookstore. The manager wants to predict the sales from the number of sales people working. So this section's on linear regression. And what we do with linear regressions is we're going to collect data. We're going to look at the data. Maybe if it has like some sort of correlation or it looks like a straight line, we can write an equation of a line. And then that equation of the line will help us to predict something. Okay, that's what we do with statistics most of the time. And so the data we have here is the number of salespeople working and then the sales in thousands. So when 2 people are working, you get 10,000 in sales. When 3 people are working, you get 11,000. When 20 people are working, you get 26,000. So the math is already done for us. Basically, it says the regression analysis shows that R squared is 92 or 93.2%. That's pretty strong. The dependent variable is the sales, obviously. So the assumption is that there might be a correlation between the number of salespeople and the total sales. They give us the intercept, and they give us the coefficient. So they've given us our line of best fit, okay? So now we got to answer all these questions. It says, what is the regression equation? Well, oops, is my thing plugged in? Oh, I got to write my little pen thing and make sure it's plugged in. Yep. All right, so for part A, and I'm going to write this over here. For part A, we got to write the line of best fit or our regression equation, which is basically the model that we're going to use. So basically, for part A, our sales then, using a mathematical model, is equal to, and we write it a little different. So we're going to write our Y-intercept first. And that's the initial condition. So remember, this is if there are 0 salespeople based on the equation, okay? So that is our intercept. It's a positive correlation. And then if you take the square root of R squared, you should get 9.9134. It's hard to write and talk at the same time, times the total number of people. Okay, so that's our line of best fit. Now for part B, it asks us what the slope is. Well, B sub 1 is our slope. And that is the multiplier in front of our, in math terms, we would call it the independent variable, right? So the independent variable here is the number of salespeople. So you would say that that is equal to, why does that do that to me sometimes? Oh, because I hit the thing. I hate when that does that. And so it would be this 0.9134 number. And then there's, let me go back and read part B. So first I need to know the slope. So this is my intercept. And remember, according to the notation, this was B naught, right? And according to our notation, this was our slope. So that's where those numbers are coming from. And part B, it says, what does the slope mean in the context? So we know what the slope is, but what does it mean? Yeah. So it's but you could put in your own words. So you would say in thousands. So another way that you could think of it is, because you're going to make an extra $1,000 times, it's a scalar multiplier, right? So the slope is up and over, rise over run, but it's a multiplier. So this would mean that for each additional salesperson, this is supposed to be a dollar sign. You would make $913.40 per each salesperson. And I'll explain what that means. So you could think of it as like a unit rate. Okay, so when I look over here, on average, if I had 8 salespeople, I plug that in and I multiply it by that, and it represents this number in thousands. So in other words, for each additional salesperson, I am expected or predict I'll increase my sales by $913. Does that make sense? So now let's do part C. Part C says, what does the Y-intercept mean in the context? So for part C, it's B naught, which is the intercept, and that's the prediction that you would make when you have no salespeople. Now, no means 0 salespeople. You'll still make money even if you don't have salespeople. What would that be? Well, it'd be the same thing. You're going to say 8.1006 times 1,000, because that's the unit that we're measuring the salespeople in. And so you're still going to make 8,160 cents. Now, I kind of glossed over it, but think of it like this. Your sales would equal 8.1006 plus 0.9134. How many salespeople do you have? 0. So then what happens over here, what's 0 times 9.134? 0. And you're left with this number here. But remember, the scale, I don't know if you guys are picking up on it, the scale is in thousands. So my sales would be 8.1, and that's where I get this. If I multiply that by the 1,000, with 0 salespeople, I'll make $8,100.60. Okay, any questions on that one? Oh, here. So now for part D, it wants me to make a prediction. What happens if I have 18 salespeople? So if I have 18 salespeople, my sales would be equal to 8.100, that's a 0.6 plus 0.9134 times 18. And I'm going to get out my handy dandy calculator. I encourage you guys to do the same, because we need to practice using the calculator. Of course, it'll take a second to load up, but we need to practice using the calculator. I got 15 monitors going on. So let's clear this out. And we're just going to plug it in. So I'm going to say, let's do this. 8.1006 plus 0.9134 times 18. And I hit enter. And then now remember, that is my number in sales. So what do I do with that number?
Times 1,000.
Yeah, multiply by 1,000. Okay. And let's take a screenshot of that. Oops. Hold on, I can't do that yet. Now I gotta take a screenshot. And we'll put that in there. All right, so let's minimize this. And I'm gonna put that in here. Oh, shoot. So that would be 24,504 18, which means if you multiply that by 1,000, it should be 24,540. They rounded weird. The textbook says 540, but it really should 541. I'm trying to figure out why they rounded down. Because technically, it should be, you could even round it to 542. So I don't know why they did it that way, but we'll just go with it because that's what the back of the textbook says. So that's what that means. If you have 18 salespeople, you're expected to have 24,000 in sales, okay? Which is a little weird, but... All right, so now let's do part D. You like the sound effects? Or I mean part E. So now for part E, they want to know what the residual sales. So the residual, remember the residual is, does anybody remember the formula for residual? Isn't it Y minus Y hat? And do you guys remember what that means? The observed value, what the value actually is, observed, minus the predicted. I probably should read the question. I just jumped right in with the answer, okay? So the question, if we scroll down here for E, is they are telling us that they had 18 salespeople and they actually had 25,000 in sales. So this is the observed value. This is Y. Okay? So I just want to be a little more formal. This is actually my predicted value, right? Because it's based on the formula. So this is my predicted value. Now, I'm not 100% as to the reasoning why they rounded down, but sometimes in statistics, you do things that kind of cook the books in your favor. So sometimes you would round down because you're like, you don't want to be too far off, okay? And we'll talk more about that later. But anyways, so what am I going to do? Well, to find the residual, it's just going to be, technically this is the same as the sales observed minus the sales predicted. So you could say sales hat, all right? And so then this would be 25,000 minus 540. And that is equal to, wait, it's 24. I wrote down the wrong thing. Yeah. This is 24. Yeah. My bad. So then this is equal to 460. Now there's some information here that's helpful to us. What does that tell us about the residual? So part F is, okay, what does the residual tell us about our value, right? So the residual is positive. And so if you have a positive residual, and this was in your notes, so it's very common that you would like not remember all this stuff. If your residual is positive, then you have an underestimate. Remember that your predicted value is just an estimate. And that's okay. And so in general, when you do these linear regressions, sometimes you have underestimates, sometimes you have overestimates. In theory, if it's a good correlation, the sum of these should be pretty close to 0. Okay. Any other questions on that? Okay. Was that the one that you